Okay, in this video we're going to be covering the Taylor and Maclaurin series. This is how it's defined. If a function f has derivatives of all orders at x equals c, then this series, right here, is called the Taylor series for f of x at c. This is important. If c equals 0, then the series is a Maclaurin series for f. So that's what you have to remember. It's all about C here to distinguish the difference between the Taylor and Maclaurin series. Let's look at it in example 1. This is what's given to us. F of x equals e to the 2x, c equals 0, and we're supposed to find the first 5 non-zero terms. Now right away you know that this is going to be a Maclaurin series because c equals 0, and that's what's required for it to be a Maclaurin series. So this is how we start. First we find our f of x, and then we find f of 0, or f of c, and that equals 1. E to the 2x, plugging in 1 is 1. Then we take the first derivative, f prime of x equals 2e to the 2x, and f prime of 0 equals 2. We keep repeating that pattern for the second derivative, 4e to the 2x, and 4. Third derivative, 8e to the 2x and 8, and the fourth derivative, 16e to the 2x and 16. So now that we've found all our derivatives, we have to take all that information that we have right here and plug it into this formula for a Maclaurin series. And remember, we know it's a Maclaurin series because our c equals 0. So we have to take that information and use it to find our f of 0 and all this. So you go back to the information you have, plug it in there, whatever's necessary. In this case you'll find that once you plug it all in, it's an easy answer of this. 1, which is your f of 0, we found that f of 0 equals 1, and then you keep repeating that pattern, plus 2x, plus 4x squared over 2 factorial, plus 8x cubed over 3 factorial, plus 16x to the 4th over 4 factorial. This was a pretty simple Maclaurin series. There's really no tricks, and you have five terms right here, which is what it asks for right here, first 5 non-zero terms, and that would be your answer for the Maclaurin series. Let's take another look at example 2. This is what's given to us this time. We have f of x equals cosine of x, so it's a trig one. C equals pi over 4, so that makes it a Taylor series because if it was c equals 0 it would be a Maclaurin. And we have to find the first 5 non-zero terms. So we start off the same way we did last time. We got our f of x and we plug in our f of c, getting root 2 over 2. And we find the first derivative, second derivative, third, and fourth. And I'll give you a second to see what our outcomes were. We have negative sine of x, negative cosine x, sine of x, and cosine of x. And then we have negative root 2 over 2, negative root 2 over 2, root 2 over 2, and root 2 over 2. So this time it's slightly different from the Maclaurin series because we have to take the information that we have and plug it in to this format to get our Taylor series polynomial. So we have to take all that information and plug it into everything that it asks for right there. And your answer is root 2 over 2 minus root 2 over 2 times x minus pi over 4 minus root 2 over 2 times x minus pi over 4 squared over 2 factorial plus root 2 over 2 times x minus pi over 4 cubed over 3 factorial plus root 2 over 2 times x minus pi over 4 to the 4th over 4 factorial. Again, those are 5 terms, just like what it asked for, using the information provided. Here we have in example 3, we have one more Maclaurin polynomial. This one gets a little bit tricky when finding the derivatives though. This is what's given. F of x equals secant x, c equals 0, making it a Maclaurin, and we have to find the first 3 non-zero terms. So we start off by finding our derivative, our first derivative, which is secant x tangent x, and when we plug in our c, we get 1. Our second derivative is secant cubed x plus secant x tangent squared x. When we plug in our c, we get 0. Well, for that one we plug in, we get 1. The previous one was 0. Then our third derivative, we have 5 secant cubed x tangent x plus secant x tangent cubed x. And when we plug in our c for the third derivative, this time we get 0. And this is where it gets tricky. Your fourth derivative, if you'll notice, is 5 secant to the fifth x plus 18 secant cubed x tangent squared x plus secant x tangent to the fourth x. And when we plug in our c, we get 5. So you have to make sure you know how to do derivatives in order to do these Taylor and Maclaurin series. This time, we get all the information that we got, plug it into our Maclaurin format, and we get our answer of 1 plus x squared over 2 factorial plus 5x to the fourth over 4 factorial. And it only asks for the first 3 non-zero terms, so that is another successful Maclaurin series polynomial. And that's Taylor and Maclaurin series.